Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on hypothesis testing for the mean using p-values. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 2 of this video series on this PowerPoint. And we're talking about how do we use the p-values to do hypothesis testing. And remember, if the p is less than alpha, then we reject HO. If the p is greater than alpha, then we do not reject HO. And a way to help us remember this is if the p is low, the null must go. If the p is high, then we let it fly. Next, let's look at another example. Here we have some times: 21.7, 23.7, 42.8, 30.1, 30.5, 33.3, and 34.5. Assume normally distributed and sigma unknown. Test the claim that the mean time is greater than 25. Use an alpha equaling to 0.05 level of significance. So our first step is to input the data into a TI-84 or 83 calculator. Choose Stat, then Edit, and Edit under the Edit menu. Type in your data. Once we have done that, let's go and write our null and alternate hypothesis. So we will find the alternate hypothesis H1. We will look and it says test the claim that the mean is greater than 25. This is what we want to prove, and it does not contain a condition of equality. So it goes into the alternate hypotheses, that the mu is greater than 25. Next, we need to find the null hypothesis, HO. The null hypothesis, HO, will be the complete opposite of the alternate. They must always be opposites. So what is the opposite of being greater than 25? Would be less than or equal to 25, remembering that the null must contain the condition of equality. So we have for the null that the mean is less than or equal to 25. Remember that some teachers will just put equal to here. Set up the calculator to do the hypothesis testing on the mean. So for the setup, choose Stat, then Test, then the t-test. For your t-test, again we're inputting our data, so make sure that the data is selected. The second line there is mu sub 0, which means we need to put in the number that we're testing the claim against. What do we think that the population mean is? And in this case, we think it's 25, so you will type in a 25. The list is where we typed in our data. In our case, I told you to put it into list 1. Frequency is the next, and we don't have a frequency, so we also leave that as 1. Mu with the 2 dots asks us to determine whether we're testing for not equal to, less than, or greater than. Since we're testing the claim that the mean time is greater than 25, and our alternate is the mu is greater than 25, remember that we'll always look at the alternate for this line, and since that's greater than, we will select the greater than symbol and make sure it's highlighted. We can select either the calculator or the draw, and actually I will show you both results, and it will be best for you to look at both results on your calculator as well. So select calculator to do the hypothesis test, and then return to the menu and select draw to see the graph. You cannot select both at the same time. You will have to return to the menu to select the second option. Here are the results for both options. Again, you can only see one result at a time. With the magic of a PowerPoint, I can show you both results. The next thing we want to do is to write down our alpha and our p. Our alpha comes from the problem, and the alpha is the level of significance, which in our case is 0.05. Our p-value is the area in the tail made by the data's t-value. In this case, it's given to us as 0.0335. And again, remember, we've decided to round to 4 decimal places. Since this testing, the claim is greater than, the p-value is the area in the right tail. And that's the H1. The claim is greater than 25. That's the greater than. And notice that we shaded the right tail. So this is the area to the right of the t-value, and it is 0.0335. Notice anything significant, well, notice our t-value is 2.2326. The area to the right, or our p-value, the probability of being to the right of that, is 0.0335. And next we're ready to compare the p-value to the alpha value, which was what I was trying to jump to earlier. And I was trying to jump to this. Our alpha value of 0.05 level of significance is now drawn on top of the graph. Notice that it is an area greater than the p-value. That means our p-value is low. It is smaller than our alpha value. If the p is low, that means it is unusual, and the null must go. That means we need to reject HO. Since the p-value is less than alpha, then reject HO. This is unusual. It would be unusual to get a t-value of this nature and the p-value and the probability of 0.0335. Here is a summary of our results. We have our problem. We have the null hypothesis of the mean less than or equal to 25, the alternate hypothesis of the mean greater than 25. Our calculator reminds us that we're testing that the claim is mu is greater than 25, a t-statistic of 2.2325, and we would round that to 2.326, and a p-value of 0.0335. It also gives us the x-bar and the standard deviation, as well as the number of data. Our alpha is 0.05. Our p is the 0.335. Our p is low, so we will reject the null, so we reject HO. Since the p is low, the null must go. And then we need to write our sentence to conclude the problem. The sentence says, using a 0.05 level of significance, there is evidence to say that the mean time is greater than 25. And I do not know why I clicked and that did what it did. You got a picture of my desktop. Oh well. So we have time for one other example. So now we have the lengths of 12.4, 12.1, 18.5, 16.4, 11.4, 14.4, and 13.3. Assume that normally distributed and sigma is unknown. Test the claim that the mean length differs from 13 using 0.05 level of significance. Again, input the data into the TI-84 calculator, selecting Stat, and then Edit under the Edit menu. Under List 1, type in your data. We need to find the alternate hypothesis, and we'll read the claim to find that. We want to test the claim that the mean length differs from 13. Remember that differs from 13 means not equal to. That means it will go and become the alternate hypothesis, again because this does not contain the condition of equals to, and because it's what we want to prove. So the mean does not equal 13. Next, we need to find the null hypothesis, or H0. And since H0 has to be the opposite of not equaling 13 is to equal 13. Next, we want to set up the calculator to do the hypothesis testing on the mean. We will press Stat, over to Test, and then choose the t-test. Under t-test, we're still doing data, and this time we're testing it against the population mean of 13. Our list is still in list 1, our frequency is still 1, but the alternate hypothesis is not equal to, so that's what we're testing our claim on, and so we will select not equal to. So we've selected the not equal to. We will then select Calculate, then go back and select Draw so that you can see both options. Notice that this is a two-tailed test, and we've talked about that in earlier videos. Not equal to gives us a two-tailed test, and that's clearly shown in our picture. Next, we want to find the alpha, or our significance level, which is again 0.05. There won't always be this, but for the examples we were doing, Mrs. Borlaug stayed consistent at using 0.05. Our p-value is the area of the two tails made by the data's plus or minus t-values. Even though it just gave you the positive values, there's actually a positive and a negative t-value. And the p-value total is given as 0.3119. Since this is testing the claim differs from, the p is the area in two tails made by the data's plus or minus t-values. And we can see that in our t-test to clarify that, and in our claim. And our p-value equals 0.3119, which is the total area in the two tails of the plus or minus t-values. And we have a positive 1.1041 and a negative 1.1041 for our t-values. And since it's different from, that will be a left and right shaded area. And the total area in those two tails, again, is the 0.3119. Next, we compare the p-value to the alpha value. And the level of significance is 0.05. That tells me, again remember, if the p is low, the null must go. If the p is high, we let it fly. And in this case, our p is high. Since the p-value is greater than the alpha, it's an ordinary value. And by being ordinary, we do not reject. And since we do not reject, let's go through a quick summary of our results. We have our null at the mean equals 13, and the alternate, the mean doesn't equal 13, and our test results from the t-test. That gives us an alpha of 0.05 and a p-value of 0.3119. Since the p is high, we will let it fly and do not reject HO. And since we do not reject HO, that gives us our sentence of using a 0.05 level of significance. There is not evidence to say that the mean length differs from 13. We have another example, but we've run out of time on this video. Please join us in the next video for another example.